Yeah. Hello. A very warm welcome to the fourth ASQF Net Week. I'm very happy to present Henri today with this talk. And my name is Anna-Christina Feldhusen. I'm working here at the ASQF, and this is the fourth time. And this day especially is sponsored by Quentinel. A very big thank you for that. And before I hand over, some information for you. This webinar will be recorded. You can ask questions with the question tool, but you can also raise your hand digitally. Then we can unmute you, and so you can talk directly to Henri, to our presenter. And yeah, Henri, it's your turn with visual web testing and the future of scriptless testing, and have fun.
Thank you. Thanks a lot. And thanks for ASQF for inviting me. And thanks for having the whole event about testing, as testing is still a bit of a niche in its own. It's really good to have all of these events and all of these webinars and organizing these bigger events where we can share our experiences and all of that. And I think I also dressed appropriately for testing. So this is something that mostly people will get. So what I'm here to talk about, let me share my screen so I can get it. No, not that. That's something else. Here we go. So what we are talking about today, it is about what we call quality intelligence, going over the whole testing space and not just talking about in testing or anything like that. What we think of quality intelligence, how can you get the intelligence about your product and what the level of quality is in there, and focusing on raising the abstraction. So this is something that we are talking a lot about, on how to be more efficient in testing, how to be more efficient even in coding, and all the other stuff that's going on in the programming sphere that's happening is that many programming languages have been raising the abstraction levels throughout, and I think testing and all of these tools are the next thing where that will happen, and that's why we chose the topic as visual testing and OCR and AI as one of the bigger topics. So thanks everybody for being here and want to listen to this. Who am I? I'm Henri. I'm a science buff, a sci-fi geek, and I'm also working in PhD in software engineering about how startups and smaller software companies, when they're beginning, how their actual software assets limit the business models that they do, but also how to verify and validate that they are actually doing the right thing. And that's my foray into testing and all of this, how I ended up at Quentinel is talking a lot about how to know if your software is working the way that you want it to, but also on the business side. And I think that also relates to the phrasing of the abstraction. Done a lot of stuff. My background is computational systems biology, so I'm a biologist, not an engineer. Well, I'm 100% engineer myself. So I say I'm an engineer, so a different kind of a biologist. Then skydiving, so a bit of that. Maybe that's the entrepreneurial stick in there, and machine learning and even AI. So I'm really good at making PowerPoints. And I think the main topic that I want to kind of talk around testing and talk around this phrasing of the abstraction of programming languages even and testing is making us all better magicians, basically. What we are going to talk about today, oh no, sorry, I forgot the company slides, of course, we have that in there. Quentinel is a company that I'm representing and where I'm working. What we are doing is we are doing cloud software testing. So we are focusing on creating the next generation of testing tools in the cloud. We are offering pace.quentinel.com as a product. It's free to use, free trial. We run Drop-out framework on the cloud, and you can scale up or use as little as you need on the cloud. All the editors are in there, it's AI supported, and all of this stuff that I'm about to talk to you is something that we are kind of pushing into the product and want to give to the developer community to use through our products, the SaaS business model that we are doing. So you pay for what you use. We currently employ 24 people. We used to employ about 200, but we're now focusing directly on the deep technology side. So we are not doing consulting anymore. So we are doing just the tooling and just all of the testing tools that we are doing in there, and focusing a lot on the cutting edge. So AI, visual testing, OCR, all the new forays that we think will be super important in the future. And we are part of quite many EU research projects for this. Testamat, IDOR, Wisdom, these are some bigger research projects supported by the EU and really wanting to get the EU into the best technology projects and really compete with the big US giants on those levels. And as I already said, the main product space, testing cloud-based on Robot Framework. Robot Framework is something that originated back in the day, I think 2006, 2008 from Nokia, but actually Sentinel was the company developing that. The people who were developing that were working for Sentinel back in time. So we have a big experience on creating testing tools and frameworks in there, and now we're going to the cloud. Today's topic is most of the predictions on future software. So predictions on where this whole scene is going, a little bit about AI and generated code and how it relates to testing. Then we are going to talk about the visual testing and OCR, which was the topic of the talk. And in the end, we're going to have some demos and examples that we're going to go through. So it's not just talk, we actually can show you something that we've been doing and actually show the stuff that I'm talking about is coming. Some of this stuff is, of course, in the future dreamland, but I think it's necessary to dream today to actually build that stuff tomorrow. Some predictions in the future. I think currently one of the trends what's happening in software engineering and has been happening for a long time is the raising of the abstraction of software development. If you think back, originally back in the mainframe days, you really had to go in and work on actual memory management, work on all of that level of nitty-gritty actual development. You had to know the processor architecture really well. You did sysop calls. You actually wrote basically assembly code, and even that is actually raising of the abstraction of that. And looking at the history of software languages, we are slowly raising the abstraction level of all of the tools that we are using to actually generate that software, which actually creates some kind of human value, some human interactable element, or calculate something quite interesting in there. And if you look at the history of programming languages, we've been slowly getting to a more abstract level and more abstract level, and also the actual languages become more and more productive. If you compare the productivity of writing nowadays Facebook, for example, with assembly compared to then writing with JavaScript and all of the modern front-end tools, for example, you are in a total different level of productivity. And that's, I think, main themes. And that's why I think this low-code movement that's been talked about a lot is going to go forward, even though now some of the low-code tools that people are talking about, create your website by yourself and all of these kind of empowering tools, which are really, I think, democratizing the software development market, even though now they are in their niche market of their own, and there's always place for hardcore engineering and all of that. But I think this movement towards low code and AI supported and generated code will continue. AI engine system will be leading to more and more generated code being used in production. And I think this is happening even now. A lot of front ends, for example, are generating their own data models for the front end. You cannot anymore trust, for example, the XPaths or something that's in the DOM, for example, in the browser when you're doing websites or web testing for those. That doesn't really hold true anymore. The data storage is stored somewhere else and dynamically created for the user. The HTML page is manipulated in ways that's not maybe in the original HTML spec or anything like that to make all of these tricks that we are now really used to on front end. And I think both of these trends will cause more and more problems with traditional deterministic testing approaches, where you always know what's going to happen in the code, and you always know if the test is going to, or okay, you do not know if it's going to pass or fail, but you're basically talking about deterministic testing. The test will either fail or pass. And that kind of situation might change to a situation where the software works properly 99.999% of the time, and that's good enough, but we can never promise 100% working. Of course, you cannot do it nowadays, but with non-deterministic systems or AI, for example, in there, it makes for a much more difficult to test system where you want to test the system logic, but maybe the system behavior is something that we want to transition more to test. And this AI thing is also something that lets us offload a lot of this computing and thought, speaking as a developer now, from our head into the process of computing, just letting us focus on what's important and really like raising the abstraction, raising our productivity. So we don't need to do what I talk about assembly. We don't have to understand pointers or memory managed in the same way as the computers themselves can help us with that. And that's true with Java. It's true with many of the JavaScript. For example, Python is now super getting a lot of traction as a programming language, and it really is upping the ante in there. And you don't have to do all this low-level stuff unless you're really doing something specific, and then you can of course learn it. And I think this is also something that's quite important, is that you have the high-level abstraction, but you can always deep down. And AI, I think, will help us interface with these kind of systems and data in ways that we not yet envisioned on programming languages. And what's going to happen? And another facet of this is then GitHub influence, low-code influence, and code generation influence. What's actually happening also in the industry is that the percentage of code written in-house is dropping constantly. For example, with looking at many of the modern websites and looking at many modern companies making websites, for example, the percentage of code written in-house is super small. The size of the node modules, which basically imports all the stuff that other people have written as open source, is I'd even wager 95% of your project is situated in node module. You might not use it all. You might not know which parts of node modules you use. There's just this random payload of code that you've basically pulled from the internet that does its magic, and you put your own magic touches on top of that, and it kind of works. And I think this is also pointing already into the direction that does it really matter if this code is generated by humans in the kind of this GitHub open source ecosystem or intelligent systems. And this kind of opens up a nice little discussion about what's being actually done in-house and what level of actual code nowadays is being generated as you are building on top of all of these different systems made by somebody else which you do not control. And of course, we've had a lot of security issues and all of that, and we had our own tumbles with this as we had some dependency confusion attacks going on, and the really interesting stuff that's happening in this space, that you're really dependent on a lot of other factors than just your in-house code. And I think this quote, as I've been alluding to magic more and more, is that any technology sufficiently advanced is indistinguishable from magic. And kind of we are quite far from just taking the computers and using them as calculators. We can now do basically whatever with just our cell phones and all of that. And how can we make this usable and understandable for all? Make sure that features actually work, and how to make sure that our AI also knows how to use those systems and actually support us in trawling through data. And this is the one interesting point that overlaps with testing, is that basically what we're doing here is teaching our systems to interact with the testable systems in the same way as a human does, using the same inputs as a human does. So basically talking about visual testing is you're using the same information that you get into your eyes from the screen, and use that as a basis of actually testing out what the website or application, or I just talk about websites, that's mostly what we test, but we can test whatever is that in the same way as humans interact with it, the actual testing software can interact with it in the same way. And maybe in the future give hands to AI, basically. If we have built the system to give out that automation in there, then just adding up intelligence behind the curtain, so to say, will make for really nice RPA setups, for example, maybe in the future. And this is, well, what I just said, I should have skipped to this slide, is basically that's why I think the best place to start building this kind of integration is in software testing and in validation, and in such way that it's easy place to do it. If you start building it on the user side, it might be something that is not seen as something that people want, but in testing it's really needed now, so it really drives the absorption of that model and knowledge. And that's where we come to image recognition and the core topic that we were talking about today. And this is just all the background that I think is quite important in there, is that image recognition technologies enable us to do that kind of system where the machine interacts with the same way as humans do. We do not rely on the code behind the curtain, behind the actual website, or dig out the XPaths to certain elements to test if they are on the screen. We can use visual information that is this element in there, and can we use that? And I alluded also to the fact that many frameworks have transitioned to generating front-end DOM code by themselves, so we don't even know what the final version of the code is. And for example, small changes in the source code might lead to big changes in the actual DOM used in production because of this, because the actual framework does all the generating of the front-end code. So a small change that shouldn't change that much triggers a different kind of a cascade tree in there, which results in totally different kind of a DOM in there. And this also drives comparative testing more easily. For example, testing on visual information. Has something changed on the web page? We take a screenshot, compare that to the new screenshot, easily identify if something has changed. And this kind of a different way of doing comparisons is I think super important next step in testing, and where we are going to end up with that. As this also enables us to test a lot of legacy stuff. It enables us to basically test technology agnostically, as all of the UI is basically created for the same API, so the human eyes, human interaction to the desktop and mouse. If we can simulate that, we can basically test any system that's built to be interacted by humans, and that's typically the difficult ones. If you have systems which have been built to only interact with through actual software APIs, those are typically quite easier to test because of the fact that they've been designed to work with just computers reading the data from there. The human interaction part is the difficult part. And I also put in this scriptless testing into the heading of my talk, because I think this is a very interesting point to make. It's a bit of an oxymoron. I don't think you can have totally scriptless testing as in the word theatrical scripting. It's more like a theater manuscript. What I want to do, for example, Cucumber is a good example of kind of this kind of a flow where you actually define what you want the software to achieve, not how you want it to achieve it. And this is also a change that we're seeing more and more, that this is the direction that we seem to be going into, and specify to the computer, I want this thing to happen, and not I want you to do it this way. In many applications, of course, there are a lot of activities about this doesn't hold true, but happening a lot in low-code environments. I want these elements in the web page to be like so, and I want this button to be here, and I want this button to be here. A lot of like AppGyver, a lot of these low-code websites are now actually being used quite a lot to create small business websites, web stores, and all of that. All the heavy lifting is done in the background by automated systems. So more of a theater script than a programming script is what I'd aim for with this scriptless testing, and then mixing of other elements than just text into the actual definition. I want this to look like this, for example, or when you do go into this website, it should be like this. And I think that's the future of testing, that is not just limited to explaining in there what the elements should be and what elements should be found on the website. It's more about interacting with the software through the same mechanisms as humans are the end users that we want to actually use it. And I think there is a lot of potential in that way. And looking at, for example, I just took the Finnish National News Service website, for example, and starting to really like dig into this stuff is what I've been talking about. Is on the screen, you can always go and dig on all the H3 storyline, headline, no elements, and you can already see that that's also generated. There's a bit of a hash in the end of the name. All these new news, for example, on this front page are being generated by an AI algorithm, recommender algorithm. So how do you efficiently test that kind of a system where the actual front end changes? And really, what we've been looking at is we of course want to have a list of all the possible news items that could be there, and have kind of a different kind of oracles that actually give the information to the testing system. And what should be there, not too much about where it should be on the page, but then do that through visual comparison. You really cannot, if you also look at the article and the source code, the DOM list on the bottom, you really cannot trust these DOMs too much, as they're all kind of dynamically created nowadays. And that's why, for example, what we are doing with our scripting, this is QWeb script, which is now open source. It's our web testing library. Is that we are doing, this is like imperative language still. So what we want to actually do with the scripting, it doesn't matter if you read this, it doesn't reference any XPaths. It doesn't reference any of the like DOM elements listed in here. And you can see that it's not too technical. it's understandable by managers, it's understandable by business, it's understandable by hopefully quite many people with just a little bit of looking into what's actually going on in the script. And that's also, I think, the idea of scriptless is that it's easy to understand by non-technical people also who haven't spent years looking into all of these different scripting languages, is that you have really concise and clear keywords on what's actually going. You want to have set the app into some state. This is of course the difficult with websites. It's actually quite easy. You just point at the URL. You click on a text called accept, change location, click text global, and verify the automated software just in case the base text is found from there. And nowhere in this page we're actually referencing what technology we are using to identify these identifiers on the web page. And I think that's also what's happening with AI and all of this, is that AI is not going to be on advertised on every single front end. It's going to be behind this kind of a simple script or something like this. You don't know AI is being used. You don't know if OCR is being used. You don't know if image recognition is being used. You just write the tests that you want, and they work, or they don't work, or they failed successfully in the right phases of what you want to happen. But the tooling that actually does the decisions on how to actually verify if these elements are there happens in the background, and happens with modern technologies, or happens with AI or OCR. In this case, we can do both. We can run the same script with OCR, no problem, and we are actually running it with OCR. But nowhere in this script it says it's using image recognition AI or OCR. And just to show you an example also of this actually in usage, being used on mobile, for example, this is an older demo from the Testomat research project, where we did a short demo. Oh no, seems like the video doesn't reset. If I was testing it out earlier, so I was checking it. We did Ponce, a project for the Fleet Manager, iOS, Android, and web application. They're using it for, let me pause that for a second. So the same application is running on iOS, Android, and web. Totally different coding environments, totally different environments to actually run the testing. But when you write it with kind of this way that we build testing scripts, you're not dependent on the core technologies behind it. You're doing it all through the UI. And for the image recognition scripts, it doesn't matter if the screenshot comes from or the video stream actually doesn't come from an iOS device, Android device, or a web application. It doesn't matter. We can run the same test basically on all the 3 different platforms and really shove down efficiency, or increase efficiency, and also shove down maintenance, because the same script works in multiple places. And this is the actual application running. You can see the actual test scripts on the right side. This is streamed from a mobile phone. So just to demonstrate different kind of environments, where typically in these kind of multi-platform environments, the image recognition is something that's quite key. And again, it doesn't scream AI, it doesn't scream OCR, it just works. And I think that's one of the most important things that's going on in there. And this goes on to something else, but also not as a topic of today. And then there's also another aspect. You can also find this on, okay, it also resets these video streams. You can also find this on YouTube, but there's a release demo by us showing what you can actually achieve with automation. I'm just going to skip through it a little bit. I'm going to show you actual demo also in the end, but just show what my colleague Jarno is doing here. He is actually checking, writing a script to test out our kentley.github.io shop. This is our testing shop. You can go check it out if you want to. It's just the plain web store basically running on our server, so we can always point our testings to that. So it's easy to check on our internal testings on in demos, that what we're doing. And if you start looking into this script, this is all based on OCR, all based on image recognition. Again, it doesn't scream in it. All the keywords are quite easy. You can use keywords. You can press keys on page down, verifying text that Sasha the deer is there. You click on that until you find the Sasha deer in the index, add it to cart, and verify that you are on the checkout. And then you can change the size in there. You continue shopping and check for the different pages in here. And again, all of this is done by OCR. And then you also grab the contact, but forget to fill in the details. And also in this demo, because we are running on OCR, there's in the end, we're actually taking a screenshot of the actual web store that we're testing against, and we are editing that screenshot just to show that it's possible in Paint, Microsoft Paint. And looking at these kind of keywords, there's nothing too difficult about them, and just simplifying all of that technology into usable format, I think, is really important. And let's see, I'm just skipping a little bit, since I cannot. Also, the GoToWebinar front end is on top of all of this. I'm just going to show the actual testing running. So it's typically one comment is that OCR is quite slow. It's not slow anymore. And all of this is actually being executed in our cloud environment connected to a Windows machine. So we can run it all from the cloud. And as I said, we click on the execute, it's actually triggering. Now this is also all controlled by the automation, all controlled by OCR. So it's actually opening the browser, filling in the details, formatting the email field, grabbing it, using the snipping tool to get an information, opening Paint, and actually going in there, putting in grid lines. We just put in the grid lines to show that it actually works on top of even like messing up with the visual imaging in there that we want to do. And all of this is controlled by that automation script that's on the background. This is actually on YouTube if you want to go check it out more properly and see what's actually going on in there. Yeah, that's a way to check it out. And this kind of a technology is quite interesting, and then touches on the other point. What I was talking about, deterministic testing. I think there's going to be a lot of stuff happening in there that you're not looking at just the pass-fail ratios of testing anymore in the future. This is from a data set that we have about different test suites and how they correlate with each other and how the actual test results correlate on the pass-fail ratios to some features, for example. And the idea here is that if you look at all the mass of test results statistically, and because we are storing it on the cloud, for example, or in your local storage, and have access to that, we can do a lot of statistical analysis also on all of that testing results. And based on this kind of a way that we can access any kind of a system with the visual tools, we can then start looking at trends that's happening there. Access speed trend for testing speed trends is also a really good indicator, for example, for pre-test cases and tests that do not correlate with, for example, for the performance of the application. There is this, I don't know if the cursor is visible, but 378, these are all obfuscated test cases, by the way. So test sets and data source 378, and all of these others data sources can show that they don't really correlate with anything, any other stuff, not with code changes, not with anything. They do not correlate with themselves. And this was quite an interesting case that all of this data was actually coming from clients' Windows Phone tests. And of course, nowadays those don't correlate really with much of anything, because they are, of course, deploying mostly Android and iOS software and web software nowadays. So basically, all of those tests can be deprecated without actually impacting your actual software that much. And all of that is something that can be then done when you have a load of information about a lot of different testing. And this is, I think, the part of the non-deterministic testing that where we are heading, much more statistical analysis also of the results, and focusing a lot more also on other indicators of the tests and not just the pass-fail ratios. Let's see on the time. I have a problem that I don't have an actual timer in here. So I've been talking about for 30 minutes, so that's pretty good. And let me just quickly, I can show you some live demo also on this, because we have the kind of 15 minutes of time to do that. Can I do that? I'm just experimenting with GoToWebinar's sharing controls. Like so. Yep. So yeah, just quickly to show that all of this is actually quite possible from deploying from the web and testing some actual web pages, showing up, also showing a little bit of our product. As I think this is appropriate on actually showing it on our platform. So this is all built on top of Robot Framework, and that's open source, but then we build a lot of stuff around it and want to build lot of more AI stuff on top of it. So I'm just going to do a robot called ASQF on cloud. We're not going to put in any kind of fancy description on there. We're going to choose the run environment as cloud, not Pace Connect this time. Pace Connect is basically allows you to connect any kind of Windows machine or local IoT or whatever. If you, for example, building Android for automotive, you could connect actual hardware through that. We're going to do web. We also offer mobile through this. And this is also the idea that with the visual testing that we're doing, you can use the same test case on web, you can use it on mobile, you can use it on whatever device you connect basically to our cloud. And some advanced features that we do not care about this moment. And let's let it create a robot for us. Where is my robot? We're going to, of course, get a nice little demo effect here or something. And there we go. We can add a test suite. I'm just going to use our starter suite, but it supports basically any JIT that you have, GitHub, Bitbucket. Any custom JIT can also be done, but with Bitbucket and GitHub and GitLab, we of course support all the better features of that the API also supports, and we can basically use the online editors through that also. We can just choose the starter suite, and I'll show you the stuff through that. You can do some basics, notifications when tests fail, scheduler, all of that, but we're not too focused on that. We're more focused on actually the actual test cases. So what we have here is, I said we are targeting mostly in our demos this web store that you already saw from the video, but I can show you the same thing. Just the basic web store. I really want to order some of these shirts. They're quite adorable in themselves, but sadly it's just a test store. And again, looking at the text that we are offering as the scripting level that is on the script. This doesn't anywhere specify if it's using OCR or if it's using web. I know that it's using actually test execution. It's using QWeb and our QWeb model in here, but you can also switch it up to using OCR if you want to use it on multiple platforms. And you can see the library here. This is also open source. This is not the OCR library, but our web library, which does a lot of the same things. Then on top of that, we're building the OCR. And looking at these test cases, and actually our test case builder or live testing as we call it, which you can then use. I just want to show you the fact that these tests actually work the way they do, and the abstraction level holds. The actual test case scripts dig out the AI behind that actually digs out. Well, that was fast. There's no pauses in here for demo effects, so it quickly ran through the text. But what's interesting also, because we are using this kind of visual testing approaches, we can do this. And on the left, it recognizes where I go to. It always saves it as the script that we're doing. Clicking on I agree, now we are doing that. We are looking for ASQF, for example. Type text to field Q, that's that identifier that Google uses there. And we can go into the ASQF, click text ASQF, it finds this page. And when we click on any of these, for example, we can quickly navigate there and it saves that file in there. Then we can, of course, put in visual reference images. We can, I should have prepared a demo for that actually. It's visible on the demos on what we have on YouTube, but I don't have any kind of nice reference demo to do you for now. But basically the idea is the same, that you can drag one of these icons and look for a certain image or a certain bitmap from the web page. And if you get a close enough match, there's some sensible defaults in there that helps you do all of that. And you can also check all of this information about the visual testing from our help pages. There is a test developers guide for computer vision. So it's all actually live. You can go and do it. And you can also test it out with our free trial. So it's not just me talking about it. and there's all of these tutorials on how you actually can get these kind of test cases to run totally on OCR when you check on through our help. And there's a little bit of a tutorial in here to help you guys get into actual workings of it, and looking at some of the debugs that you can also get from there in the robot log, because it's based on robot framework. It outputs nice logs also for you on what's actually going in there that you can check. So you can check out all of this if you want to, and there's a lot of materials on how to actually get it running. But going into back into basically, I'm just going to do this. Going back into, oh, okay, it starts from the beginning. Let's go into this nice ending slide. So basically, what I think is the future of testing is that the actual usage of all of these high technologies like AI, OCR, all of this will become ubiquitous. You will not see it in the actual test scripts that, hey, I'm here using AI, or the AI is doing something smart in here. It's all going to be hidden behind the curtain and be, as we said, like magic, that the whole thing actually works. You do not interact with the code as much anymore because of the code is being generated more and more, so it's more dynamic in what's actually happening in the source code side. And so you have to do a lot more through the same APIs as humans do it. So visually, or even through sound, or through some other user interfaces that we also been looking at, is like haptic and audio cues, for example, for cars. That's something that's happening a lot on Android automotive side, for example, that you have audio cues and you want to test those. So it's also a whole different world that can be done on that side. And the interactions that you want to test, it's going to change. So visual, I think it's #1 now, because of course humans can get the most information out of visual elements because our eyes are so good senses in there, compared to, I don't know, nobody I think does user interfaces based on smell. That could also be a good thing. Sounds bad, but yeah. So testing out those kind of interfaces where the OCR and all of these elements are key is something that's going to happen more and more, and AI will be more and more integrated in there, and actually the whole testing space will change in there. I think I'm a little bit ahead of schedule, but I'd still say that I'm done. Thank you for listening, and hopefully I wasn't just rambling around and talking about things that don't matter that much. I think these matter quite well, and hopefully everything was interesting. And if we have any questions, I can take questions.
Thank you so much, Henri, for this interesting presentation and for the demo. We already have some questions that you can also see as of right now. I will read the first one. Oh, it's a pretty long one. As always, when using AI, the good parts may look very promising, e.g. when the AI is able to identify the correct elements and deduce the user intent from its input. However, with mismatches or false positives, things often get hairy. Have you already found an easy way to improve the model, e.g. interactively, when the user reports an error in the learned model? And also, are users also able to edit the model or use more lower level scripting statements?
Yeah. That's actually a really good point. And I think one of the main hidden problems with AI is how to update your models, how to keep models up to date, and how to actually train them continuously to make them better and better. And also, that's one of the reasons why most of our technology is in the cloud, so that we can actually do this based on all the data that we have in there. And as you said, in testing, for example, I think false positives are one of the most difficult things, and we've tuned our models in such a way that we want to limit the amount of false positives. False negatives are not too bad. That lets us learn more efficiently through that. False positives are dangerous, as you said, and we offer, for example, you were saying that if you want to go deep down in there, you can. All of this stuff actually, if you dive deep into the actual editor that we are using, is basically you can, if you don't want to use this high level, it's something that I also alluded to at some point. You can always dive deep into the actual source code. You can dive into the XPath. You can do all of that, and you can even write your own custom stuff with Python if you, for example, want to. We, for example, are running all of our own testing on Pace, and we sometimes have to also dig deep into those XPaths that we're doing in there and use that. I think there is no easy way to interactively improve those models, and we are doing that on the background based on our cloud platform and doing it for you basically, but it's not easy.
Okay, thank you. So there's another question from one of our other speakers. How can I interact with icons with no text descriptions? It seems that I still need selectors for that. Am I right?
You can interact with them just based on the image file currently. And something that we want to do is enable this kind of comparative testing, but that the actual implementation of that is easy, but the problem actually stems from the fact that where do we store all the reference artifacts and how do we do that easily? So currently we are looking at the actual test descriptions on some parts, or the system kind of falls back to those test descriptions, but you can always take reference images, for example, of those and put them into your test case and then just do a compare. There's a keyword for us to click icon or click image, for example, but the problem still of the easy to use is where do you want to store those reference artifacts and how can you do it programmatically? And that's something that we are actually now working on creating a nice artifact storage for that kind of information that is not basically text-based. Source code GitHub handles that really well, but if really it is, you need, for example, reference images that has something changed on your website. You take a screenshot during your test run, you save that, but then you want to compare it. We all already save screenshot or even video of the test runs, but the comparison part of that is difficult if you don't have an easily referenceable artifact storage. So that artifact storage is the problem that we are solving next on that, so that we can enable that you to more easily do that kind of visual comparison straight away with just the keywords. Now you unfortunately have to include the files in the GitHub repository to do that comparison, or you can use an S3 bucket or something else to store that. I'll dig around if I have some examples of that, and I can even get back to you and show you some examples of that. But that's something that you can quite easily do, but it's not as easy as we would like it to be.
Okay. So another question is, when the robot file says click text something, is the AI able to understand which some text to click on when the phrase is multiple times on the page or not visible at the bottom of the page?
Yeah. And this is also a really good question, and something that I kind of skipped over because what we use on there is what we call anchors. You can say that it should be on a certain point of the web page, and we're actually, when you're using this online editor, we are actually saving some of those anchors on where in the page the text should be found, for example. And this is, for example, you might have a problem with tables, or you have a SAP or Salesforce website, which is notoriously painful. That you have the same thing in for example, a sheet or a table in there, and you want to find a certain row, and that's something that I think is one of our favorite problems because of that, because it's difficult to identify that I want this line in there. But typically with humans also, if you want to find a certain text, you always in your head also associate some metadata with that text the same way that you want. I want to find the help menu text, which is actually on the menu ribbon here on top, for example. So there's always like kind of some kind of metadata information in there, and we are also digging that metadata information to identify the right keyword in there, which is the right click text. Or if you're just using plain click text in there, it will actually dig also through the identifiers in the XPaths behind there, but just doesn't tell you that it's also doing that, to make sure that when you do it through the cloud editor, it actually finds the right one. hopefully I answered your questions. Both questions I kind of answered on the fact that yes, we want to do all of that super easily, but there's some real world problems on actually making it as easy as it can be.
Yeah. Yes, at the moment there are no further questions, but if you want to, you can also ask questions in German. We will try to translate, and Henri told me before that he can understand a bit of German, so that's also a possibility. But I still want to take the time to talk a little bit about the ASQF for the ones who don't know us yet. We are an association since 25 years for now, with about 1,300 members, and we are also offering a special price for the Net Week to participate, to get a reduced membership fee, only 40 euro if you want to, and what do I want to talk about? Our other English webinars. We have mostly the Net Week is in German, but we have also other English webinars. There's one from Clemens Reinen this afternoon at 5 o'clock about from audit-based to continuous validation and other practices cloud teams adopt. And tomorrow, one from Marco Berger, confidence booster, how to sleep like Tutankhamun with proper testing pyramid. And also just register on the ASQF.de/netweek for all our other webinars, for our evening discussions about agility and test automation. On Thursday, we would be very happy to see you there. And there are no further questions. So one more thing, you can network with each other on Humby. I just sent the link to the Humby networking area from the ASQF. And you can meet up there. It's pretty low entry. You just need audio and video. It's working in the browser, and we would be very happy to see you there, my colleagues and I, and maybe Henri has also a little bit of time to answer further questions there. And I wish you a pleasant day, a good start into the week, and see you again.
And thank you from my side also.
Bye-bye.